Hello, this is Robert Guderian, and today we are talking about how functions can be passed information and how that is maybe not always what we hope it'll look like. This is actually a pretty tricky concept, so don't be afraid if it doesn't make sense right away. It is subtle, and that's the worst kind of problem. So we've seen how to pass functions some parameters. So we can easily write a function right here saying def. Remember that we have to do this before we run our code. And we're going to say sum of numbers. And we're going to say 20. I'm going to say, x and y, a and b, first and second. And then we can just quite happily return first plus second. And then down here I can say print sum of numbers and pass in 10 and 20. I can do that in my head, always a good thing for debugging. 30. And hey, look, it says 30. I must have done something maybe not wrong. Okay, so we know that the first argument gets slotted into the first parameter. The second argument gets slotted into the second parameter. Good. That's not too bad. We know a little bit about scope. So what I can do is start storing these in some variables. I could even use input, but I think that'd be more complicated than it needs to be. So I'm going to have a different variable name. I'm going to say 1 and 2. Just because this is an example and there's not a lot of context. If there's actually context, I could have better variable names. But this works for me. 1 and 2 gets passed into first and second, and this will still sum to 30. Not bad. What if I change first up here? What's going to happen? Well, 1 is equal to 10, and I'm passing in 1 as my first argument. So first is going to be equal to number 10, because that's what I'm storing in the variable 1, which is, in hindsight, maybe not the best variable name. Then I'm overwriting whatever is inside of first, and I'm going to have 100 plus whatever I pass in a second, which happens to be 20. So I believe that this will be 120. But what is 1 equal to now? We just changed this first, and first and 1 have a connection right now because I passed it in as an argument. Well, we can check. Variable Explorer. This is tiny for you. I'm aware of that. It's still 10. I can even check it here just by typing 1, and I'll say it's 10. Okay, so we know about scope. We know that I can't easily change my 1 variable up here. It'll complain saying that I'm not allowed to do that. We can force it to do it. Don't do that. But I'm currently changing something, and nothing's happening in my main line. Well, that's good. Well, what has happened is that this function is isolated, and any changes I make to whatever I pass in 2 parameters, well, nothing happens. This is called passes value. So the concept here is that with primitives, so that is our ints and floats, and that's it, because Python, we pass these in as a value. And you can also say pass as copy. That's sometimes a better way to imagine this problem. I'm going to introduce you to a programming concept that is very important. And I draw this for every single class, any chance I get. And that is that when we call functions, we can always track the function that we were called from. And then when we're done that function, we'll go back. So as we call functions A, B, C, and D, we're going to go back from E to D, C, B, A. So it always goes out and then back in the same route. Well, we can imagine that as what's called a stack. Our main function is always our first function. And of course, Python kind of abstracts that from us. It still does run. It still is a thing. In this case, I have a second function called sum of numbers, and that has to fit in here. And we're passing in two integers. We're passing in the number 10 and 20 in this case. And we're passing them in as a copy. So imagine this. I have a number on a piece of paper. Then I'll make a copy of that piece of paper and give it to you, and you will have your own copy of that piece of paper. In the context of our program we just wrote, this is a variable named 1. It was my first argument. I had no better name for it. This one is called first. So if I switch over to my program, you'll see that I've 1 is a variable here. That's my box on the left. First is over here. That's my box on the right. If we did this and I gave you this piece of paper, and in this is me handing you a piece of paper, if you do some graffiti on that and you go, it's 100 now, which is exactly what I did in my program, the original is untouched. Okay, so that means that you can do whatever the heck you want to your copy, and I don't care. All I say is that you have a copy of this and you can destroy it. Mine is fine. That is passing as a value. I'm giving you a copy. You can destroy it, whatever. And from our example here, these numbers that are coming in are copies. So primitives, I spelled that wrong, are passed as copy. We call it passed as value because of the way that this is actually implemented in an operating system. There is something called a runtime stack, and this is what this is called. And as we call functions, those will go up, and as those functions return, they go down. As you add a function, it'll go up 1. As we go down, it'll go down 1. We'll see this a lot once we touch recursion, because this concept is really important. Okay, so that's nice. Everything's great. We love it. I have another example of it in my slides. I do approximately the same thing, and it's untouched. Now, this one, in my slides, I don't even return anything. I just try to destroy a number, but it's a copy, so I destroyed a copy, and flatly no one cares. But you can see the pain on my face. Imagine not everything in the world is a primitive. Are you ready for it? I'm going to say the thing. Objects are data and methods to work with those data. That is a semantically correct sentence. It still feels bad. Okay, so now we've seen some objects in my code. I'm going to make a new function. I'm going to call it sum of array. And I'm going to pass list. I'm going to pass in a list. And then I'm going to space that out just for your visual consumption. I could use the sum function, but I'm going to do it manually because I feel like I should. No, I'm not going to do it. I can do this as a one-liner. I can't help myself. Return. There is a built-in function to get sums. Check it out. But before I do that, let's make sure this works first. So some data is equal to 1, 2, 42, and 9001. Oh. It's so important that I need to type that right. And then we're going to get the sum is equal to sum of list. And we're going to pass in data, and then we're going to print that out just for good measure. I can't actually add this. Oh, okay, 9001. So this is going to be 9043, 9045, 9046. I did a math. I'm so proud of myself. So that works. Life's great. List.append 10,000. So now we're going to add a 1 to that. So the result here will be 19,046. I have to think about how to phrase that. Hey, I'm right. What's happening up here? What does our data look like? Let's just print it out down here. 10,000 is added to it. And that is going to be here too. We have changed our variable. Inside of this method, I added 10,000. And now, well, let's just even, to really prove this point, print out data before. I'm going to say, before. And I can cast this into a stir, which will force it to print out nicely. After. I am a good typist. I'm not. I never have been. All my friends type faster than me. Why is that there? Oh, because I call. It's not about the print. It's about calling the function. Ah! Now I know I've mentioned that I'm bad at copying and pasting things. If you think that I was lying to you, there we go. You can see that before I call my function, and especially if I print the print before I call that function, that 10,000 is not there. Afterwards, 10,000 is there. I have printed out data here, and it is changed. Let's talk about pointers. Let's talk about runtime stacks. Let's talk about how much I love talking about pointers and runtime stacks. So we have our function main, which is so beautifully drawn. And then we have sum of list. That's also a function. And I'm passing in a list. But I'm not actually passing the list. That's the trick. What we have is two different data structures. We have the runtime stack. And we have something called the heap. You can really consider this as your random access memory, your RAM. You've probably tried to get as much of that into your computer as possible to make it run as fast as possible. Consider it like your workbench. You can only work on things that are on your workbench, and if your workbench is full, you need to take things out, and everything you know currently is on your workbench. This is where we store objects. Objects go here. Okay, so we made a list. We checked it twice. And we put it here. 1, 2, 42, 9001. I'm going to leave a little bit of space because I know that I'm going to ruin it. And in my code, I named it data. And I pointed to it. Can you see why this is called a pointer? And when I passed a list, I passed the pointer. Now, hard nerd mode, and this is not testable in this course. Functionally, what we're passing is an integer. This is a memory address to a place on the stack. So we are passing a primitive. We can only ever actually pass primitives into our functions. A pointer is the primitive, but we actually care about the object, which is out here. If that didn't make any sense, that's okay. If it did, awesome. But what we get, the result is that sum of list has a list in it. That was the name of my variable. And it's pointing to the same place. So now when I make a change, that will cause this to change. And I'm not changing a copy anymore. I'm changing the real thing. So going back to the example of me and you having some kind of transaction, this is like me saying, well, my car is over there. It's an object. It's big. And the keys are in it. You can go use it for a while. And you're going to do things to it. And it's going to physically change this object. Like if you scratch it, we're scratching the only copy. There is no idea of copies going around. There is only one instance of this object, and you are modifying it by using it. Then when you give it back to me, you're not giving me back, you're not saying, I'm done, and saying there's a copy. No, you're saying this. We'll talk about stacks more. The stack will collapse, go down one. And I'll look at my pointer, and you have fundamentally changed my object. And I may or may not know that. I should, as a good programmer, going back to actually programming, predict that you have changed things. The car example, there's going to be less fuel. There's maybe going to be a scratch. There's going to be more kilometers on the odometer. You have changed that object. And you may not have, right? I may pass a pointer to an object to a function, and that function might not change anything. It might just use it, might only read it. And that's good. That's what we usually expect, but that's not always the case. Neat. So when I did this, example of adding 10,000, when I re-inspected data in my code on line 25, I looked down this line. This is called dereferencing for not testable. And then I looked at this data and I saw 10,000 in it. So that is passing as reference. Objects are passed as reference. Cool, let's do it with a string. Def change a string. This is a string. And we're going to say a string is equal to a string plus is smart. I thought about saying something disparaging. I won't. And then I'm going to make my name. No, I shouldn't say my name. I should say somebody else's name. I wish this was in class. I'd say, what's somebody's name? I'm going to call you smart in front of everyone. I'm assuming that there is someone named Sarah. Spelled thusly. There's a lot of ways to spell Sarah. So I'm going to print out the name before. And then I'm going to add the name. And then I'm going to call my change a string function. And I'm going to pass in the name. And then I'm going to print after. And I should put a space there. I didn't. Plus the name. Oh, that's an L, not a thing. There we go. Okay. Name. Kerming. Okay. So now, because of what we know about objects, we know that strings are objects. I've talked about it ad nauseum. I'm sure you're tired of me talking about it. It didn't change. Did Rob just lie to you? Well, no, I didn't. There is some subtlety of, first of all, finding the scene that has my slides. Strings are immutable. I'm not allowed to change them. So what does that mean for our runtime stack? We're going to get to draw this one more time. And for our string. So we have our runtime stack. Main. Change. I'm not going to name it change a string. We know that the name is out here. We know that we're pointing to it. We know that when we pass in initially, it points there. Now, when I run the line of code on line 14 by changing the string, and I am definitely changing the string, there's no doubt about that. What happens? Well, I'm not changing it. Actually, this is assignment. You just functionally can't change a string. Well, what happened? Even if I had better methods to do this, like modifying a tuple, you can kind of almost look like you're changing it. What's going to happen is Sarah is smart, S-M-A-R-T. then a string instead of initially pointing to Sarah is now pointing to Sarah is smart. This stack is going to collapse. My function is going to return eventually. I'm going to be back in my main. I'm going to inspect this pointer. What am I pointing at? Well, I'm still pointing at Sarah. So when we made a change to an immutable object, we tried to destroy the old one, but we basically just removed our pointer from the old one. We created a new object, and we pointed to that new object. That old object, though, Sarah, in its original state, is untouched. And you're thinking, well, this is needlessly complicated. Yes, but so many programmers have screwed up strings in functions, and then the people who called those functions got upset that they made strings immutable. So strings feel like primitives. I'm going to put this... Oh, that is the worst. I tried to make it italics. I failed. Itives. I know how to spell primitives. I just always put an A there. So you feel like you're passing in as copy. Like, oh dear. I'm getting very excited. This is one of my favorite topics. Almost everything is my favorite topic. I really just enjoy what I do. Okay. We are going to try out a lot of these. We're going to have some examples. And it's actually a good thing. This is a good thing. So objects are passed as reference or passed as pointer. There is only one that exists. Primitives are passed as a value, a copy. Immutables, so that's tuples and strings, they work the same way as objects, but you have to remember that they're immutable. That whoever called you will still have a pointer to that original tuple or string, not the one that you're hacking up. So, I hope you're having a good day. I'm looking forward to discussing this with you further.